So this is something I found out. Okay. What about a minus 3? That's also straightforward. So a17 equals a3 equals 3j. And this implies that a minus 3 is minus 3j. So all of the four Fourier coefficients that you require to find, you can find. Okay. Is this enough to determine what the signal is? So is this enough to determine what the signal is?
Yes, sir. That's enough.
How?
Because the period is n and the period is 7. No, it's not enough. We need 3 more coefficients.
Yeah. So does that mean we don't have enough information?
Yes, we do not have enough information.
Okay.
Because there are a total of 7 unknown harmonics.
Yeah.
We just find out the coefficients for 4 of them. 3 are still unknown, so we cannot be sure about the exact shape of the signal.
Okay. So the question once again is, do we have enough information to determine x of n? And the yeah. So we, off the top of your head, I mean, you take it. We need 8. We need 7 coefficients to be able to determine.
So we have information. We do.
Okay. Why?
Because we have 7 of them, because we can find out the coefficients from the range minus pi to pi.
Yeah.
And so we have the signals from a minus 3 till a3, which are equal to 7 number of distinct coefficients. So that's why we can find out the exact value.
Yeah. So you see, the signal is odd and the signal is real, and because the signal is real, there's additional property of conjugate symmetry that the
Yes,
coefficient should satisfy. So let me just write them out. So a plus 1 was plus j, a plus 2 was 2j, and a plus 3 was 3j, right? And what we don't know is a4, a5, and a6, right? But these can be determined very easily. How? Because of periodicity. So a4 was actually equal to, is going to be equal to a of minus 3 as well. Why? Because of periodicity. 4 minus 7 is minus 3. And a5 is going to be equal to a of minus 2, and a6 is going to be equal to a of minus 1. And these are things we know already from up above. So this is minus 3j, and this is minus 2j, and this is minus j. So सारे के सारे पता है हमें, ठीक है? So it's because of the symmetry of the problem that we're given, specifically because the signal is real and odd, ठीक है, that we just actually need 4 coefficients. Okay, बाकी all the other 3 can be determined from those 4. Okay, so यहाँ पे कोई question?
Sir, Assalamu alaikum. Sir, how do we know that we need 7 coefficients?
Because the period is 7.
Sure. Okay.
So the period is 7.
So we need to find 8, right?
J?
We have to find 8 coefficients or 7.
We need 7 coefficients. कोई कहीं भी हो जाएगा.
Okay, got it.
As long as they're in a single period, that's enough. Okay. अच्छा. किसी और को भी confusion जी उस्मान?
Sir, sir, अगर हम a minus 3 से लेके 3 तक find करना है,
that's
तो
also
वो भी तो enough होगा.
Yeah, that's also fine. That's enough.
Oh, okay.
Any more questions? जी हमजा.
So why do we need even coefficients to build an odd signal?
It's not about even number of coefficients to build an odd signal. It's just that any capital N equals 7 है, ठीक है? So that means there are going to be 4 coefficients that you will need, right? Sorry,
Yes.
there are going to be 7 coefficients that you need, ठीक है? और 7 coefficients में there's a symmetry property, right? So इसमें जो a naught है वो a naught के बराबर ही है, minus a naught के बराबर होना चाहिए, so that's something you know. और बाकी 3 इस साइड पे जो पॉजिटिव साइड पे हैं वो there's a function of the 3 on the negative side of it, ठीक है? And that's how you know कि जी ये वाले 3 मुझे पता चल जाए, तो ये वाले 3 भी पता चल जाएंगे. If this was 8, right?
Yes.
Capital N was equal to 8. So then what would have happened?
We would have needed 8
Not
coefficients to build this.
No, not necessarily. You would have needed उस केस में कितने चाहिए होंगे? उस केस में भी
7 ही चाहिए होंगे, I think. A1 equals to A8 हो जाता.
हाँ नहीं, so you would need 4 in those cases as well. ठीक है, you actually need 8, ठीक है, लेकिन there's going to be a symmetry property that's going to be satisfied, right? So
Yes.
A naught actually 5 आपको चाहिए होंगे. So A naught to A3 आप निकाल लें अगर, ठीक है, तो A -1, A -2, A -3 और A -4 भी चाहिए होगा आपको.
Yes.
तो A -4 एक अलग चीज आएगी, ठीक है. So I would have to think about this a little bit more. लेकिन off the top of my head, I think you'll need 5, and the other 3 could be determined from those 5.
Okay, sir. Thank you.
Any other questions?
अस्सलाम वालेकुम.
Islam?
सर ये मुझे एक्चुअली बात समझ नहीं कि अभी आपने पहले कहा कि हमें जो पीरियड है उसके अकॉर्डिंग मतलब कि जो कोएफिशिएंट्स हैं वो एक ही पीरियड में लाया कर रहे हैं.
Yeah.
तो हमारे पास उतने हैं तो हम डिटरमिन कर सकते हैं. लेकिन ये जो 8 वाली एग्जांपल थी ये मतलब बिल्कुल मुझे कंफ्यूज कर गई है.
तो 7 वाली आगे समझ.
जी जी.
क्या समझ आई?
सर मतलब आपने ये कहा है ना कि एक पीरियड में अगर वो कोएफिशिएंट्स लाया कर रहे हैं, तो हम वो वाले कोएफिशिएंट्स फाइंड कर लें तो हमारे पास आ जाएगा सिग्नल.
तो यहाँ पे आप 7 निकालने थे, तो ये 3 काफी क्यों, 4 काफी क्यों थे?
ये बात समझ नहीं आई मुझे सर.
ये वाली भी नहीं आई ना, तो 8 वाली पे तो नहीं जाना फिर आप.
सर ये बता दें प्लीज.
So it's because of the symmetry property, conjugate symmetry, right? So if you go through the properties of the 3-time Fourier series, that says that for real signals, the Fourier series coefficients have to satisfy conjugate symmetry, right?
Okay.
वो क्या होती है conjugate symmetry? सना आपसे पूछूं.
सर उसका जो conjugate है वो a k is equal to a conjugate minus k.
Good, right? So for real signals, a k equals a minus k conjugate, right?
जी.
So because of periodicity, मैं ये भी लिख सकता हूँ कि a k equals a conjugate n minus k.
ठीक है.
ठीक है. तो इसका क्या मतलब है कि अगर मैं if I'm only visualizing the Fourier series coefficients from 0 to n minus 1,
जी.
तो ये अगर 0 है और ये n minus 1 है, ठीक है, तो फिर वो कोएफिशिएंट यहाँ पे जो 1 पे रिजाइड करता है और जो a n minus 1 है ये आपस में रिलेटेड है.
बिल्कुल सेम होगा. वो
सेम नहीं होगा, कॉन्जुगेट होगा एक दूसरे के.
अब ठीक है सेम होगा.
ठीक है, इसका मतलब ये वाला आपको पता है तो a minus 1 पता चल जाएगा.
ठीक है.
ठीक है. फिर आपको अगर a2 पता है, ये 2 है,
तो an minus 2 पता चल जाएगा.
an minus 2 पता चल जाएगा. ठीक है, इसके दरमियान में एक रिलेशनशिप है एंड सो ऑन.
सही है.
जाते रहेंगे.
ठीक है.
एक सवाल है.
जी
थैंक यू सर।
सर यहाँ पे हम लोगों ने कॉन्जुगेट सिमेट्री वाली प्रॉपर्टी निकालनी है या यहाँ पे हम लोग और सिग्नल वाली भी प्रॉपर्टी दिखा सकते हैं?
दोनों एक ही बन जाती हैं इस केस में। अब the conjugate symmetry भी, क्योंकि the signal the coefficients are purely imaginary, ठीक है, तो उसका conjugate is actually just multiplying by minus.
Okay.
So if this was a more general problem in which the coefficients would not necessarily purely imaginary, so then you would have needed the conjugate property, not the minus property.
Okay. Okay. Okay.
Okay. Should I go on? All good questions? Okay. So the next thing I want to do is, if you recall, problem 18E exercise C. Actually, ये वाली. So I'm not going to solve it here. I'm going to leave this off for you to do on your own. So remember, इसको हमने जो modules में content जो recorded content है उसमें one of the ways we did this was to visualize this signal here as this square wave which has amplitude of 1 plus a DC signal, ठीक है, और उससे हमने उसको निकाल लिया था. But this is an alternate approach in which I visualize this signal as a sum of this square wave of amplitude 2 plus this square wave of amplitude 1, right? And for this, you would have to find out the Fourier series coefficients for this thing first. Right now, this does not exactly lie under the category of this signal. Why? Because this is from minus n1 to plus n1. You cannot write this as from minus n1 to plus n1 and shifted or something, because this is the total number of pulses within a wave is actually even, whereas यहाँ पे odd होते हैं, ठीक है? तो इसके लिए just very quickly, and this is also going to review some of the things that we done earlier. So yeah, right. So this is. So I'm going to try to do this very, very quickly because this is related to the things that we've done early. So this is a square wave once again, okay, except that this square wave is different than what we've seen earlier. And how is it different? It starts at 0. It starts at 0 and it ends at n1. Okay, so this is a generalized, you can think of this as a generalized shifted form of what we've seen earlier. Okay, so let me do this quickly. So it's a solution. So I'll just apply the analysis equation here. So analysis equation is right. So what does this turn out to be? Who's going to help me here? Where should I sum from where to where? जी अरसलान बताइए कहाँ से कहाँ तक सम करूँ मैं इसे?
Sir, minus n to n plus n1.
But this sum has to be over one period, right?
So minus n1 to
here.
So 0 to n चाहिए.
0 to n.
0 to n, right? 0 to n minus 1 actually. Okay, so you're doing it over one period. So this easier thing for me to do is to sum it from 0 to capital N minus 1 because that's one period, right? And this is x of n e raised to power minus j k 2 pi by n times n. This turns out to be equal to 1 upon n, and this summation just reduces to summation from 0 to n1. इसको मैं थोड़ा सा चेंज कर लेता हूँ प्रॉब्लम को. मैं यहाँ पे -1 कर देता हूँ. Right, that may make things easier. and this is e raised to power minus j k 2 pi by n times n. How do I evaluate the summation? What is the summation equal to? Ji Hamza Malik, what is the summation equal to?
So 1 minus the exponential raised to the power n1 minus 1.
So this is n1 minus 1 hota, n1 hota. So you just count the number of terms inside the summation, and that's n1. Okay? And divided by 1 minus the exponential. Now, how do I simplify this further?
So we can take half of the angle outside and
Excellent.
then write 1 in terms of e to the power plus exponential multiplied by e to the power minus exponential.
Good. So this is what I'm going to take outside in the numerator. So this is e raised to power plus j k pi by n times n1 minus e raised to power minus j k pi by n times n1. And in the denominator, I'm just going to take out minus j k pi by n, and this is e raised to power j pi by n minus j k pi by n. And so this is e raised to power minus j k pi by n, and this is n1 minus 1. Okay. What do I have here? ये क्या चीज बनेगी?
Sine.
Sine, good, right? So this is a sine in the numerator, and this is sine pi k divided by n times n1 divided by sine pi k divided by n. Is this it, or is there something, a corner case that I have to deal with? Is this the final answer? So there's a corner case which corresponds to k equals 0. So this holds true for k is not equal to 0. What about the case when k equals 0?
A naught would be 1.
No, not necessarily. Why? Why do you say it's 1?
So because from the above analysis equation, if exponential is 0,
Yeah.
then there will be 1, and no, we will still have to find x of n. So
Yeah, so
it
x of
won't
n
be
is 1. So you just go back here. Okay?
yes.
Hamza, you stay here. So k equals 0 मैं डालूं अगर. So this is just 1, right?
Yes.
If I have a 1 here and I'm summing 1 how many times? n1.
n1.
Okay?
So it would be n1 over n.
Good, excellent. So this is your answer. One of the things I want to say here, and this is something I observed in the midterm as well, by the way. For some reason, students try to deal k equals 0 always separately. मैंने एक question पूछा उसमें k equals 0 वाली चीज़ अलग से निकाल रहे हैं, k is not equal to 0 वाली चीज़ अलग से निकाल रहे हैं. You don't have to do that always. Why do I do this over here? I mean, why do I treat k equals 0 separately? क्यों Nimsha?
Sir, because if we took if k was equal to 0 and we place it inside this, we would get 0 by 0, which would give an infinity sign.
Yes. So it's not infinity. I mean, so you'd have to evaluate what it
Like
is.
undefined.
So that's why we deal with the k equals 0 separately. But otherwise, if you don't run into that problem, you don't have to specify this for cases ke k equals 0 ke liye hai, k is not equal to 0 ye hai, and so on and so forth. Okay? So I just find a corner case in which I run into a problem in which there's a potential for 0 by 0 thing. Okay? Acha. So you see here, this is almost similar to the square wave thing that we done earlier. Okay, I'll encourage you to take a look and see how this is different. This is slightly different. Slightly different इस तरह है कि एक तो ये इसके अंदर shift आ रही है, right? So this is a shifting operation going on. Okay, so there's a time shift, and that indeed is a time shift. As you can see कि वो ये 0 से नहीं start हो रहा, वो इधर से -n1 से नहीं start हो रहा, 0 से start हो रहा है. And the other differences are over here, and that I encourage you to take a look. When n1 is the total number of, so when n1 is even, you'll see this automatically relates to what we had over there. Again, in one of the examples in the class. Okay, so this is why I wanted to do this quickly. Now you can use this equation into exercise 18 and plug it in and see whether you get the same result or not. Okay, that's one of the ways you can do it. Okay, iske andar koi questions? Okay. जी क्वेश्चन है कोई?
Yes.
जी बताइए.
Sir, can you explain the math in the second line where you open up the summation, remove the summation?
यहाँ पे?
Yes. How do you get here from the left side?
So this is a finite series relationship.
Yes.
Okay, so a finite series relationship क्या होती है? N equals 0 to n1 minus 1 a raised to power n. What is that equal to? That is equal to 1 minus a raised to power capital N1 divided by 1 minus a. This is what I've used.
Oh, okay.
ठीक है, तो आप इसमें a जो है, a is just this thing here. A is this thing here.
Okay.
ये है.
Thank you.
This is a. ठीक है?
Yes. Thank you, sir.
अच्छा जी. अगला करते हैं. So Jamshed, are these the kind of problems that you were talking about? You're now given some information about the signal and its Fourier series coefficients, and you're required to find what the signal is. Okay. अच्छा जी, किस तरह करें? Sorry, Jamshed, the question was, what if k were 0? I didn't see this. So I can come back to this later. Let's deal with this problem here. So x of n is real and even. Okay. X of n has period n equals 10 and Fourier series coefficient a sub k is a11 equals 5 and this 1 upon 10 summation. So this is average power is 50. Okay. Which reminds me that quiz mein you were required to find the average power, right? And some of the solutions I saw very, very quickly, glanced over them. They have tried to sum the Fourier series coefficient with sine upon pi k wale the. That's not the way to go about it. Okay, uske baare mein sochiye. So you would use Parseval's theorem in the quiz solution, by the way. Okay, for problem 1. Achha, so that was tangent anyway. Achha, so ye given hai, and you're required to show that x of n is actually a cosine, and which has a certain frequency and a certain amplitude and a certain phase, and you're required to determine the amplitude, the frequency and the phase. Okay, so is तरह करेंगे. So who's going to help me? Andy. So A1 equals 5. Okay, good. So that's the first thing I do. Okay, I know that A11 equals 5, right? Which means that A plus 1 equals 5 as well. And why is that? Because of periodicity.
So A minus 1 is also equal to 5.
D?
A minus 1 would also equal to 5.
Yes. So, and because since the signal is real, actually you don't need to, signal is even, chale. A minus 1 is going to be equal to A of plus 1, which is 5. Okay. So I can therefore claim that A9 is also plus 5. And so A9 is also 5. A9 किसका आया 5?
It's due to the periodicity property.
So once
A
again,
minus 1
minus 1
is
plus
equals
9.
to. Yes, yes.
ठीक है? तो अच्छा, अब do I have enough information? I mean, how many वैसे Fourier series coefficients do I actually need? I need A0 through A9, right? So I need several of them, right? But this constraint 4 actually tells me that all of the other coefficients must be 0. How's that? Ji, Hamza?
So we can get an expression in terms of a case from the fourth point.
Fourth point, so Parsev's relationship, right?
Yes.
So from Parsev's relationship, I know, so from Parsev's.
Sir,
Yeah?
can we take the coefficients from A plus 1 to A11?
So that would be 10 that would be 11 coefficients.
Okay.
You need 10. Okay? But you can do it from A plus 1 to A10. That's fine.
Okay.
Okay? However, you see this? अच्छा चलिए ठीक है, that's also fine. No problem with that. Okay, no problem.
Okay.
Okay. So from Parseval's relationship, I know that 1 upon 10 summation n equals 0 to 9 x of n absolute squared is equal to summation k over any period absolute of ak squared. Okay. And let me just take it from k equals 0 to 9. Right? And what do I have on the left hand side? So this thing here is 50. It was given to me. Okay. Is this enough for you to conclude that बाकी सारे coefficient 0?
Yes, sir.
Okay. So because you know two of the coefficients. One of the coefficients is 5, which is A1. Okay. And you also know that A9 is also 5. Right? So that squared add karen, so that's 25 plus 25 is 50. Okay. So that means all of the others must be 0. Okay. So since A1 equals A9 equals 5, all other coefficients must be 0. Right? So from here, I conclude that my x of n, I'm just going to write it out as the analysis equation. So as x of n is synthesis equation. K equals 0 to 9 ak e raised to power j k 2 pi by 10 times n. Okay, so this is a1, which is 5 e raised to power j pi by 5 times n plus 5 e raised to power j 9 times pi by 5 times n. ये cosine है, ये how is this a cosine? So how is this a cosine? जी हमजा आपका क्वेश्चन हमजा या पहले का हल करा है?
सर पहले का हाथ कर रहे हैं.
Okay, good. So
the second term corresponds to A9, which is also the same as A1. So 5EJ9 would also be equal to 5E minus J pi by
good.
Minus J 2 by 10.
E raised to power j pi by 5 n plus 5 e raised to power, अगर 9 pi by 5 में से I subtract 2 pi, right? So 2 pi is 10 pi by 5. So 9 pi by 5 minus 10 pi by 5 is minus pi by 5. Right? And which everything is consistent here. So because it's the same as a minus 1, I could have actually done this as well. I could have actually summed this from minus 1 all the way up to 8. And I would have actually gotten the same result. Okay? So what I get here is 5 cosine pi by 5. Right? So this means that A equals 5, which is the amplitude. The frequency is pi by 5. And the
so what would be 5 by 2 cos?
Yeah? Oh,
so 5 by,
sorry.
5 by 2.
ठीक है. Thank you. So this is actually 10.
Yes, 10.
This is 10. Thank you. So this is 10. ठीक है जी? Any questions here? Okay, so let me move on. So this is problem 3.28 from the textbook. And I've decided not to do part C because part C becomes very tedious. So I'd like to do other problems there. I just do part 1 here, which is we're hopefully going to be able to do quickly. So part 1 कैसा करें? So part B basically, that's what we're doing. So what is the period of x of n? So what is the period of x of n? So ऐसा कर लेते हैं. What is the period of sine 2 pi n divided by 3? Fundamental. 3? Good. And the period of cosine pi n by 2? What is this?
2.
4. So what is the overall period?
12.
12. Okay. And for x of n, I'll just use Euler's expansion here. So this is 1 upon 2j, and I'm going to skip a step here. So this is 4j. This is e raised to power j 2 pi n by 3 minus e raised to power minus j 2 pi n by 3. And this is e raised to power j pi n by 2 plus e raised to minus j pi n by 2. And let me, so they're going to be 4 terms when you multiply it out, right? And let me just write them out directly. So it's 1 upon 4j e raised to power j 7 pi by 6n minus e raised to power minus j 7 pi by 6n. This is plus e raised to power j pi by 6n and minus e raised to power minus j pi by 6n. Okay, so it's one of the interesting things that I just wanted to mention was, you see, this is actually a trigonometric identity. I mean, sine multiplied by cosine is sine A times cosine B is sine A plus B plus sine A minus B. ठीक है, तो आपने असल में उसको Euler's expansion से derive कर लिया, right? So you don't really need to remember a lot of stuff. You can just use Euler's expansion to derive all of those trigonometric identities. So this is what you get, and I've skipped steps here, okay? And then from here you can quickly see, okay, because that is 12, so so this is 1 upon 4j e raised to power j 7 times 2 pi by 12 times n minus e raised to power j minus 7 times 2 pi by 12 times n plus e raised to power j times 1 2 pi by 12 n minus e raised to power j minus 1 2 pi by 12 n, and there you have the Fourier series coefficients, right? So this is a7 equals 1 upon 4j, a minus 7 equals minus 1 upon 4j, a1 equals 1 upon 4j, and a minus 1 equals minus 1 upon 4j. और अगर एक पीरियड के अंदर निकालना है तो उसको so minus 7 is actually a plus 5 and a minus 1 is a11. Okay? The C part I'm not going to do, that's quite tedious, but I encourage you to do it on your own. Okay? Any questions here? This was simple enough. Okay, so let's.
I have a question.
Yes.
Sir, we studied in the properties of Fourier series coefficients that if two signals are multiplying, we would have to convolute their corresponding Fourier series coefficients. Yeah. Is the reason that we're not doing it here is because the two signals don't have the same period?
You can actually do it here. Actually, that's a very good point. यहाँ पे जाएं. This is your. Can you apply the multiplication property here? So ये हमजा आपने पहले सोचा था, अभी ज़हन में आया एकदम से?
Sir, अभी
आया. So that's an excellent question. So what's the answer to this? कौन आंसर करेगा? So okay, so Gulhamid says no, we cannot, and I think Gulhamid's answer is no because he thinks correctly that the periods for these are different, right? However, I would tend to disagree, and the reason why I would disagree is कि इसका fundamental period 3 है, इसका fundamental period 4 है, but 12 is a period for both of these. So 12 इसका भी period है, इसका भी period है. So why don't I determine the Fourier series coefficient of this with respect to a period of 12 and the Fourier series coefficients of this respect to a period of 12, and then I can use a multiplication property. And if you do indeed use the multiplication property there, you will get the same result. Okay? So I'm not going to do it completely. Let me just quickly point out, okay, using multiplication property. So let's say x1 of n is, okay, sine 2 pi n by 3, right? So this is 1 upon 2j e raised to power j 2 pi n by 3 minus 1 upon 2j e raised to power minus j 2 pi by 3, right? But I can write this as 1 upon 2j e raised to power j and then 2 pi by 12 times n. So what should I have as something equal to k?
4.
Right, so this is 4 here. Okay? And similarly, minus 1 upon 2j e raised to power j minus 4 2 pi by 12 times n. So with respect to a period of 12, right? So this is important. With respect to a period of 12, so with respect to n equals 12, my coefficients are a4 equals 1 upon 2j and a minus 4 equals minus 1 upon 2j. Okay, so that's important. If I were determining it with respect to a period of 3, so then I would have gotten a plus 1 equals 1 upon 2j and a minus 1 equals minus 1 upon 2j. Okay, so the Fourier series coefficients change with respect to the period that you're determining the Fourier series coefficient with respect to. Okay? And similarly, you'll find, so you'll use these and then do it, so determine the Fourier series coefficients of x2 of n is cos kya tha? Cos pi n by 2. With respect to n equals 12, right? So ये आपके पास आ जाएंगे, क्या आएंगे? So you'd see this is a plus 3 equals 1 upon 2 and a minus 3 equals 1 upon 2. So a b कह देते चले. ठीक है? अब हमजा आप जो है you convolve, circularly convolve a and b's, you will get the same result as you had as over here. ठीक है? Go ahead and verify this.
सही आपने b3 और b minus 3 किसने निकाला डायरेक्टली?
ये मैं अपने सर में किया. I've done it.
सर पूछ रहा हूँ वो सर में क्या किया सर आपने होमोलॉजी का?
So basically I see कि जी इसका period असल में 4 है लेकिन मैं 12 के मुताबिक कर रहा हूँ. So +1 should be multiplied by 3. I mean that's what I've done. लेकिन आप इसको I would exactly इसी तरह करके देखें. ठीक है? So this is pi by 2. ठीक है? So this is 2 pi by 4. Right? And this must be multiplied by 3 to get 2 pi by 12. So ये चलो 2 pi by 12 है ना, टाइम्स क्या करूंगा मैं, जो मेरे पास pi by 2 आए. So this must be 3. ठीक है? So that's how I figured it out. ठीक है? Right. So Hamza, that's an excellent question. Everyone should try to do this with the convolution as well. Now convolve, periodic convolution. So you do it yourself and verify. Okay. So should I go on? जो थोड़े मुश्किल वाले प्रॉब्लम्स हैं वो कर लेते हैं. Okay. So this is problem 3.50. Has anybody done this already? Just want to get a sense. I know students जो इससे पहले वाले problems कर चुके हैं. So has anybody done 3.50 successfully? Good. Right. Anybody else? Okay. So it's not that hard of a problem if you really think about it. So there are only two conditions that's given to you. So actually three conditions. X of n is periodic with period n equals 8, right? So n equals 8 and Fourier series coefficient a sub k is. This is something that's given to you, which is a sub k is equal to minus of a k minus 4. And this is another condition that's given to you, x of 2n plus 1 is minus 1 raised to power n. And you're required to determine x of n. So you're just required to sketch the x of n for one period of, okay? So, सबसे पहले ये देख लें, what does this translate into? Right? Now, you can use the frequency shifting property directly over here. Let me just not use it. Let me just go with the synthesis equation directly. And essentially what I'm therefore going to be doing is I'm going to be deriving the frequency shifting property. So first of all, let me see कि जी पहली condition. So पहली condition का मतलब क्या है? What is the constraint that it implies on my periodic signal x of n, right? So let me say that there's let y of n be a periodic signal with Fourier series coefficients bk, which is equal to minus a k minus 4. Okay, so from the analysis, from the synthesis equation, y of n is summation over k bk e raised to power j k 2 pi by 8 times n. And इसको मैं अभी कैपिटल n ही रखता हूँ ताकि, right? So this is k equals n bk is minus a k minus 4 e raised to power j k 2 pi by n times n, right? So what am I trying to do? What I'm trying to do is I'm trying to determine y of n as a function of x of n. Okay? So that's what I'm trying to do. So in other words, on this side, I now would want to do some manipulation so that what I get on this right-hand side is something which looks similar to x of n, okay? Or is some function of x of n. What do I do? So what do I do when in doubt? Just apply. क्या कहता हूँ मैं? You apply a what? A change of variables. Okay? So I'll just do that. So let m equals k minus 4, and this would mean that y of n is minus summation. This will be m e raised to power j m plus 4 2 pi divided by 4 times n, and this will still stay over one period, right? Because if I'm summing over one period, and if I shift that by a constant amount, that summation will still be over one period. right? So it stays the same. Okay. And this is going to turn out to be equal to minus m equals summation over 1 period a m e raised to power this is a j m 2 pi by 4 times n, and outside I have e raised to power j. Actually, a 4 to nika. I've done something wrong. So this was 8. Okay. So this was 8. And this is, so 2 pi multiplied by 4 is 8 pi 8. So this is 8 pi divided by 8. So this is pi. This is pi n. So what is e raised to power j pi by j pi n? What is e raised to power j pi n? Yeah, so this is minus 1 raised to power n. Okay, good. So this is minus 1 raised to power n. And what I have here is e raised to power j m 2 pi by 8 times n. What is this equal to? So you see, this thing here is nothing but x of n. So what I conclude, therefore, is that y of n is actually equal to minus 1 raised to power n x of n.
So how is this equal to x of n?
Because that's just the analysis equation. Sorry, that's just a synthesis equation. अब आपको पता चल गया होगा अब तक from my recorded modules as well कि I keep on misplacing के synthesis कौन सा analysis equation. So this is the synthesis equation. ठीक है? And these are the Fourier series coefficients of x, okay, which has a period of 8. So this is exactly the synthesis equation of x. Okay? It does not. So if the source of confusion is the fact that I'm not using the k here, that should not be a source of confusion.
It's not.
Okay, k, m is any variable. So I could have had k here. Okay, so y of n is minus or minus 1 raised to power n x of n. But since and this is essentially what I've done is I've derived the frequency shifting property. So you could have used the frequency shifting property directly. Okay, उसमें क्या कहते हैं कि if I'm shifting the frequency, the Fourier series coefficients by a fixed amount, that's actually the same as multiplying the time domain signal by an exponential signal which has a particular form. Okay, so this is something we did in the recorded content as well. Okay, so from here, what I conclude is that since the information that's given to me is that ak equals ak minus 4, therefore this would imply that x of n must be equal to y of n. Okay, but x of n, y of n is minus 1. Y of n is this thing here, right? So this implies that x of n satisfies this condition. This is minus 1 raised to power n x of n. इससे कुछ, can I extract some information out of it? Can I determine what x is from this relationship? जी Jamshed, unmute your mic and tell me. क्या नहीं समझ आया आपको?
x of n y of n के equal कैसे?
क्योंकि this is what's given to us. See, this is the condition that was given to us. ठीक है?
minus a k minus 4 में सब condition एक दफा.
Oh yes. Sorry.
Minus.
Oh, there's a minus here. Okay, so this was given to us, and the these are the Fourier series coefficients of what? X, right? These are the Fourier series coefficients of minus a क्या minus 4 किसके Fourier series coefficient वो y के हैं, ठीक है? तो if the Fourier series coefficients of two signals are the same, that means those signals must be the same as well, because there's always a one-on-one correspondence. ठीक है जबशेद, are you there?
Yes, sir.
Right, समझ आई या नहीं? So what's given to us is ये इसके बराबर है for all k's. Man, this is for all k. Right, for all k. If this is true, that means if the time domain signal corresponding to these Fourier series coefficients must be equal to the time domain signal corresponding to these Fourier series coefficients for all k, for all n. ठीक है? So इसके time domain signal क्या है? X of n है. इसका time domain signal क्या है? Y of n है. ये के बराबर है तो ये भी बराबर होने चाहिए. ठीक है? But what is y of n? That's something we've derived over here. Y of n is this thing here. Okay, so therefore, what we conclude is that x of n must be equal to this thing here. Okay, that's a constraint that x of n must satisfy for all n. Okay, clear हुआ है? Okay. Okay, so how do I go about from here? यहाँ से आगे क्या जाए?
Can I answer?
जी जी बिल्कुल.
So we will categorize it into two parts, for even and for odd. For even, minus 1 to the power n would be plus 1, and for odd, minus 1 to the power n would be minus 1.
Yeah, good, excellent. Right, so when n is even, what are we saying? We're saying that x of n is equal to minus of x of n, because minus 1 is to power n, for even n is just plus 1. ठीक है? तो इसका क्या मतलब है? जी हमजा?
Signal is odd.
Sir, it means that the signal is odd.
It's not really odd. यहाँ पे माइनस नहीं है.
Oh.
यहाँ पे माइनस नहीं है. I'm just saying a number is a negative of itself. What is that number?
0.
0.
0. Good. Right? So whenever n is even. So 8 values आई थी मुझे because the period was 8. Out of those, I've determined the 4 values, and those 4 values are, so therefore x of 0 is equal to x of 2 equals x of 4, and which is equal to x of 6, and all of these values are zeros. What about the odd values? So this is something I've known. Odd values का मतलब है, what about the odd time indices? उस पे क्या होगा? So हमें एक और चीज़ पता है, from condition 2 we know that x of 2n plus 1 equals minus 1 raised to power n. इतना? Yeah. So how can I use this to determine x for odd values? Acha, by the way, so does this information, does this equation 1, does this tell you anything when n is odd? Does this tell you anything when n is odd? Q, Remsha?
Yes, sir.
Does this equation, the equation number 1, tell you anything when n is odd?
So when n is odd, not really, apart from the fact if n was odd, then we would have a positive sign here.
Then what would that mean?
They're both equal.
Does this tell you anything? My question is, does it have any information? Does this equation have any information?
I don't think so.
Why not?
Sure, because what information can you derive from this? Apart from that, there will be a positive sign.
Neetu, but you were deriving a lot of information when n is even, right? And that's negative.
Yeah.
Negative sign से information मिल जाएगी, positive से नहीं मिलेगी. How do you?
Sir, I'm not sure.
Explain it. Anybody else?
Sir, does it mean that x of n will take the same values for all odd powers of n, odd values of n?
No, that doesn't tell you this either. यहाँ पे किसी और ने हाथ खड़ा किया था अभी. हमजा ने किया था?
Yes, sir, I was wrong about something. It doesn't matter.
क्यों उबैद?
अगर हम n को इवन रखें तो हमारे पास सिंपल इक्वेशन आ जाएगी x of n is equal to x of n.
Yeah, excellent. So when n is even, all you get is x of n equals x of n. So when n is odd, sorry, when n is odd, okay, the equation that you're going to get is x of n equals x of n. That has no meaning whatsoever. I mean, it's just like you're stating the obvious. Of course, x of n equals x of n. Okay, so for odd values of n, this equation number 1 does not have any meaning. Equation number 2 does. Okay, how do I use equation number 2? So this is equation number 2 to determine what x is for odd values of n.
तो n को अगर आप 0 पुट कर दें इस इक्वेशन में तो x of 1 आ जाएगा और इसी तरह x3 x5 आ जाएगा हमारे पास.
So for n equals 0, so n equals 0, so we're getting x of 1 equals plus 1, right? When n equals 1, we're getting x of 3 equals minus 1. When n equals 2, we're getting x of 5 equals plus 1. क्या रह गया? N equals 3 पे we're getting x of 7 equals minus 1. ठीक है? और स्क्रीन मेरी. Right, so there you go. So that's your entire
so basically for odd numbers, the signal oscillates between those numbers. And for even it's just 0.
हाँ, so बाकी लेकिन जो odd indices पे वो oscillate करता है, right? So ये 0 पे 0 है, 1 पे plus 1 है, फिर 2 पे 0 है, फिर 3 पे minus 1 है, फिर ये है, फिर ये है. So this is here 1, 2, 3, 4, 5, 6, 7. Yeah, there you go. So this is plus 1, minus 1, minus 1. So this is x of n for one period. And of course, it repeats itself periodically. ठीक है? All right. So we're out of time. Like what I'm going to do is, I mean, for those of you who want to leave, that's fine. I mean, so I see some people have left already. Anyway, so there are a couple of more examples that I'm going to do, which are slightly more involved. और इसमें एक मैं problem, I'll assign it for somebody to try to do on their own at the end here. So this is something similar to what I said or what I typed in WhatsApp as well. Okay, let x of n be periodic with an even period n and Fourier series coefficients a sub k. And additionally, it should satisfy x of n equals x of n plus capital N by 2. What conditions will AK satisfy? So I want to go a step forward than what is straightforward. Straightforward ये है कि यार since x of n equals x of n plus capital N by 2, this must mean that AK equals e raised to power j times k 2 pi by n times n by 2 times AK. Okay, so I've just used a simple shifting property. And therefore, this implies that AK equals, so this, you see, cancels with this cancels with this, and this is just minus 1 raised to power k times AK. इससे क्या conclusion आता है आपके पास? So what conclusion do you get from here?
That AK is oscillating.
AK is not oscillating. AK equals minus 1 raised to power AK. There's something you can say about the odd valued Fourier series coefficients. So this must mean that AK equals 0 when k is odd. Okay? What I want to do is कि even values of k के लिए वो Fourier series coefficients क्या होते हैं? So इसलिए I'd like to go a little bit deeper. Okay? So for that, so you see, so additionally, AK equals 1 upon n summation n equals 0 to n minus 1 x of n e raised to power minus j k 2 pi by capital N times n. And I'm going to split it up into two parts. N equals 0 to n by 2 minus 1. And mind you, I can only do this because capital N is even. Otherwise, I would not have been able to do it. Here, capital N is even, therefore, capital N by 2 is an integer as well. Otherwise, this would not have been possible, what I'm doing right now. And then what I do is I make a change of variables. So I'm doing this rather quickly by skipping a step. E is to minus j k 2 pi by n times n. So if I make a change of variables, so this summation is from 0 to n by 2 minus 1. And this is x of n plus capital N by 2. And e raised to a minus j k 2 pi by n small n plus capital N by 2. Okay, that comes about simply from a change of variables. And one of the easiest ways I can do this, see this, is because यहाँ पे summation कहाँ से कहाँ पे जा रही है? n by 2 से n minus 1 तक जा रही है. And exactly यहाँ पे वही हो रहा है. n equals 0 जब होता है तो ये n by 2 होता है, और ये n by 2 minus 1 होता है तो ये n minus 1 हो जाता है. ठीक है? So I've made a change of variables and I've said that the new variable is also n. Okay. So here, this is 1 upon n summation n equals 0 to n by 2 minus 1. This is x of n e raised to minus j k 2 pi by n times n plus summation n equals 0. X of n plus capital N by 2 is just x of n, and this is e to the power minus j k 2 pi by n times n, and this is minus 1 raised to power k. And once again, that's because of the fact that ये capital N इससे cancel हो जाएगा, ये से cancel हो जाएगा, and thus is e raised to power j pi k, this which is just minus 1 raised to power k. And what this gives you is something interesting therefore. So this is 1 upon n equals 0 to n by 2 minus 1, and this is x of n, 1 plus minus 1 raised to power k, e raised to power minus j k 2 pi by n times n. And from here you clearly can see yahan se bhi. So this implies when k is odd, ak equals 0. That's something you can clearly see. When k is odd, this is 1 minus 1, this becomes 0, and this goes to 0. Okay? What about when k is even? Then ak equals 1 upon n. Actually, this is 2 upon n. N equals 0 to n by 2 minus 1. X of n e raised to power minus j k 2 pi divided by n times n. Right? So when k is even, the Fourier series coefficient that you actually determine or you actually compute does not need to use all of the period over the entire, all of the signal over the entire period, but rather only over the half of the period. That's enough for you to determine the Fourier series coefficients. Okay? Why do you think that is true? So Jamshed, I'm going to come to this. Yahan pe, what I'm saying is that ye conclusion kya hai? So let's just focus on the conclusion first. The conclusion is that when k is even, the Fourier series coefficients that you require, that you compute, for that you don't need the entire period of x of n. Sirf half period kafi hai. Half period kyun kafi hai?
But the rest of the values, the AK is 0. So we only take it down which the AK has a non-zero value.
The AK, this has not to do with AK, this has to do with X basically. So somebody, Usman ne हाथ खड़ा किया था या?
Yes sir, मेरा भी शायद यही था कि मेरा ख्याल है कि odd के लिए AK 0 है तो इसलिए we need a half.
देखिए, अभी do not confuse the एक domain, Fourier domain अलग है, time domain अलग है. ये चीजें कह रहे हैं कि Fourier domain coefficients निकालने के लिए मुझे time domain का पूरा period नहीं चाहिए, but rather I could only use half of the period of the time domain, and that is enough for me. I don't need the other half. Why don't I need the other half? That's my question. Yes, sir.
So I have an example to kind of explain it.
Okay.
So the period 4, if we know 0 and 1,
yeah,
and we know 2 and 4, 2 and 4 would be equal to -1.
Yeah.
And 2, -2, which would be, because it's even, -1 would be equal to 1.
Yes.
A -1 would be equal to A1.
Okay, so Hassan, I've not checked his signal is even.
No, not the signal, the A.
A भी even नहीं है. They're not necessarily even. So when I say even, I don't really mean that the Fourier series coefficients even बनते हैं. What I'm saying is that A sub k's are even. Sorry, the index k is even.
सर हम एक्स ऑफ सी के बारे में ये भी तो कह सकते हैं कि इसका जो एक हाफ है वो एग्जैक्टली उसके सेकंड हाफ के इक्वल होगा, और तभी हम उसके एक हाफ से हम पूरे कोएफिशिएंट्स निकाल लेंगे, उनको फिर ट्वाइस कर देंगे, तो लाइक फॉर एग्जांपल हम राइट साइड से निकालने को लेफ्ट साइड की भी ट्वाइस करने से आ जाएंगे.
Yeah, excellent. So here is the point. असल में what's given to you is x of n equals x of n plus n by 2. That's something given to you. ठीक है, वो खत्म हो गई. So this is what's given to you. X of n equals x of n plus capital N by 2. If you really think about this, असल में the period is actually n by 2 because of this condition. This actually condition means कि capital N तो period है ही है, लेकिन n by 2 भी period है. So capital N was actually not the smallest period that you had. There exists a smaller period which is n by 2. ठीक है? And that means कि अगर signal जो है आधे period वाला ले लें आप, that's enough because that half period tells you everything you need to know about the other half. ठीक है? That's why we only need half of the period to determine the Fourier series coefficients. And there's additional things that you could find from this, which is, Kitty, what if I were to determine, if I were computing the Fourier series coefficients with respect to period of n by 2, I would use the analysis equation, and this would be that analysis: 1 by n by 2, n equals 0 to n by 2 minus 1, and this would be x of n e raised to the power minus j k 2 pi divided by n by 2 times n. So this is equation number 3, and this is equation number 1. So relationship इनके दरमियान में क्या है? That's for something you to think about. And this is advanced. These are advanced problems. And if you want to really excel at the understanding, these are the type of answers that you should try to think about. Okay, so how do you relate 1 and 3? You'll find that there's a very specific relationship between B's and A's. And this goes back to one of the advanced problems that I mentioned in the problem solving session. Okay?
Can I make a guess about this relationship?
हाँ जी, guess करें.
Sir, BK would be a shifted version of A.
Shifted नहीं होगा, थोड़ा सा. So it would be, sorry, I'll give you a hint. It would be a time, it would be expanded version.
So can I guess?
जी, guess करें please.
BK equals to A sub 2K.
Something close, yes, very nice. ठीक है? You see यहाँ पे n by 2 में अगर n by 2 को ये इधर ले जाऊं तो ये 2k बनना शुरू हो जाता है. ठीक है? And that's 1 by, this is 2 by n here as well. ठीक है? As 1 upon n by 2, this becomes 2 by n. Right? But the only problem is when k over here is odd. And that for I know is 0. ठीक है? So, and I'm giving you the answer, maybe something for you to think about. AK is equal to 0 when k is odd, and b k by 2 when k is even. So this is the relationship. ये जब आप DSP वगैरह पढ़ेंगे तो इसमें इस तरह की चीजें काफी आती हैं. ठीक है? So this is something maybe I'll leave off for you to think about. One final challenging problem before I stop is something for you to do. Y of n is x of 2n. So इसके Fourier series coefficients अगर x of n के अगर Fourier series coefficients a के हैं तो y of n के क्या होंगे? ठीक है? This is going to be even more difficult or more challenging. Challenging. This is where I'm going to stop. I've gone